So hi everyone and welcome to the 17th session of the Nomadic Labs Research Seminar. Today we have the pleasure of hosting Haochen Xie. Haochen is an engineer at the Xie consultancy firm in Japan. Haochen is a software engineer with a focus on system architecture, and he has a background in programming language theory and runs a small consultancy firm that leverages state-of-the-art computer sciences method to tackle technical challenges. Haochen is going to present his work on TSCA, a typical smart contract agency. It is a conceptual platform where providers offer a customizable smart contract. Here's a recording. Then Haochen will have some time to answer your questions. So now here's a recording for his presentation for better quality.
Hello there. I'm going to give a presentation on a recent project we have been doing with the Tezos blockchain, which is called a typical smart contract agency. I'm Haochen from Japan, and you can find more information about me in the bio. So I'm going to jump start into this presentation. At the very beginning, let me talk about what TSCA, or TSCA in short, stands for. As the name suggests, a typical smart contract is a central piece of discussion here, which basically means the parameterizable contract templates. Well, just think about the legal contracts we have, for example, the NDAs, the home loans, the franchise agreements. Many of those, there's a template, and you fill in, for example, your name, the dates of the contract, and a few terms, and that's the contract, and ready for the parties to sign. And the typical smart contract concept basically very similar to that. So where you have smart contract templates with a few customizable parameters, and make that, and the TSC agency concept is that you create a digital marketplace for those kind of contract templates, so that the end users, they may not know any kind of advanced programming or the blockchain technology in general, but they just go to a provided contract template and fill in the information, the parameters they like, and just originate a smart contract. That's the basic idea. And throughout this presentation, I'm going to use this agenda, where I'm going to firstly give a general introduction and some non-technical overview of the TSCA prototype we have done. And after that, I'm going to give you a little bit more information about the prototyping project we have done. And after that, I'm planning to spend the main block of time explaining some technical details about our prototype architecture for TSCA, because it's supposed to be a technical seminar. And at the very end, if there's still time left, I'm going to give a very short introduction of certain, actually three contract templates that we have created for this TSCA prototype and certified with Quark. So heading to the general introduction. So basically, TSCA is, as what I just said, like a digital marketplace for parameterizable smart contract templates. So it's at a very high level, a marketplace concept where you have providers of those smart contract templates, and there's the agency that's going to look at those templates provided by providers, whether they're valuable, whether they're security claims holds, and put it out on the market. And there are end users will just visit the marketplace without too much need for a solid technical background, and they can just easily originate and interact with smart contracts that is made out of those smart contracts. So it is aimed to be, the typical smart contract agency is supposed to aim to be user-friendly and mostly designed for non-programmers and users. And for our prototype, we have specifically added Ledger hard wallet support, and it's available through a web interface. And going into more details, I want to show our flyer for this concept, and I'm going to give a very brief demo after that. So what I'm showing on my screen now is a two-page slide, two-page flyers that we plan to share at workshops, but obviously due to the pandemic that was happening. And the first page is basically a very brief introduction on the idea, but on the second page, we can see that there is a walkthrough for like the user experience to use the TSCA. So I'm going to walk quickly through this thing. So basically, from the end user's point of view, what you only need is a web browser and optionally a Ledger hardware wallet. Or if you do have a Ledger wallet, you can also use the official Tezos CLI to do the same thing. We are supporting both of them. So to create a contract with a TSCA, well, by the way, we are branding our prototype of TSCA as Tezos sign, and it's planned to be available at this address. Just by the way. So to create a contract, you go to the website, and from a list of available templates, you select one of them. In this example, we're selecting Book of Frozen, which is going to be a vesting contract. And the website is going to present you the template details, and you are supposed to examine them and enter the parameters. For example, for this Book of Frozen, you're supposed to input the font owners, the font amount, and until when the asset shall be frozen. And after that, you just finish with your Tezos wallet or in the browser. And after everything goes okay, you're going to get an URL that is specifically made for the instance of the smart contract, just originated from this whole process. And if you visit this URL, you are going to be presented with the UI user's interface designed for this type of contract, filled with information of this specific contract you are visiting. In the later views, this is called in the later technical part. This UI web application is called a book app. And with this book app, you can interact with it, like you can check information about your smart contract, and you can also perform some blockchain operations. And for example, for this Book of Frozen, there's an operation you can do it with this, of course, withdraw. And if you click that, there's going to be a form popped up, and you input the amounts you want to withdraw and to which address you want to withdraw, and you just transact. And once you do that, it's going to show the same interface that you can just plug in your Tezos wallet and finish the transaction. And if you refresh the page, you'll see that the contract, the balance held in the contract will decrease. And of course, because it's a frozen contract, this withdrawal can only happen after the frozen until has been passed. So this is a very brief introduction. Let's start the demo very briefly. So what you can see here is the top page of our current prototype agency implementation, which basically is a list of all the available contract templates, and you could do a little search here, as you can see, and you can click on those listings to check the details, as well as actually click the launch to do the origination, which we're going to do slightly later. And also, there's somewhere you could input like a spirit hash so that you can open the Bootcamp to check information about that instance, smart contract instance, or do some interaction with it, which I'm going to demonstrate later as well. So before start doing everything, let me show you the Tezos address we're going to use in this demo. So firstly, show address Alice, and we're going to copy it over here, and HCC01, sorry, it's not Bob, let's copy it over here. Okay, so you get everything here, and you can also see that we have the broker contract, which basically handles all the actual origination in behalf of the agency. The address is like here. We're going to mention that later. So the first demo I want to show is to open an existing frozen contract, which we can just input the spirit hash here and click open the Bootcamp, and you can see that the corresponding Bootcamp just shows up with the information of the spirit we just shown here. And you can see here, for this contract that I originally like a moment ago, we have a balance of 98 Tezos, and the frozen until is down to, well, a little bit before this current time. And the owners is set to account 1. You can have multiple owners, but right now we won't have one of them. And the contract, which is the actual underlying on-chain contract sitting on the Tezos blockchain. And we can actually check that, for example. Let's see. So this is BCD, a local instance of BCD, and we could see that this shows information about this frozen contract, and the balance is of course 98, and we can see the storage. It's storing the information like the orders and down from until. It's not storing the balance because it's evident from the contract metadata. So let's try to do interaction with it. If we click withdraw here, it's going to pop up open and interaction widget. There's a terms of service. We just click agree here and go ahead. What this screen is basically the actual form that you have to fill out to perform this interaction. The beneficiary field is basically where to withdraw the money to. Let's withdraw to Alice. And amount, let's do 0.2 Tezos. From here, you can actually generate the instructions for performing that action on chain. There's an option to perform this operation with ledger, but unfortunately I don't have a hardware ledger at hand, which you can do if you have one. I'm going to show you the CLI option. So what you do is that you put your name here, your email here. I'm just going to leave them as a default value for this example, and the source address that you want to perform that action. In this case, we have to put the address for account 1, SCC01. The reason is that only the owner of the frozen contract could actually perform a withdrawal operation. So we click proceed. Proceed. It's going to do an simulation, and because the simulation looks fine, so if you click it looks good to me, it's going to give you the instructions you need to actually perform this operation on chain. And you can also, if you are using Ledger, you can use this option, but we're not using it right now, so go back to CLI, and you can just copy and paste. You can see here, so basically it's doing a smart contract call from the source address you provided to the smart contract, and with the argument that the smart contract is going to understand, and if we execute it, it's sandbox, so it's quite fast. It should say, well, let's check how the contract goes. Oh yeah, you can see the balance just lowered by 0.2, and if we refresh this book app, you can see it's also refreshed here. And this basically demos how to interact with the Spirit. For the next demo, I'm going to show you how to actually originate a contract. Let's go back to the homepage and click one of the contracts we want to use. The contract template we want to use, and you can see that there are some basic facts. The most important one being the template fees, and that's part of them payable to the provider, part of them payable to the agency, and you can see that the contract parameters and the contract terms, which is basically the implementation of the contract as shown here. There's a few caveats and a few buttons help you to actually get a rating out of them. And you can see that there are formal specifications like the equivalent Microsoft contracts, the effective template, the technical notes, so on and so on. And after examining those information, you think this is the contract you want, you can click launch. And it's basically a very similar system for you to actually create a contract. So here, you are prompted to input the parameters that you want to, how you want to customize the contract template. Like the initial balance, let's give it 50, and frozen until, let's do today, it has to be the feature, so let's do 3. Yeah, and the font owners, let's do Alice this time. Actually, you can do both of them. Well, let's just do Alice here. And coming here, we just input the source address and click proceed. And the simulation finished fine. It looks good to me. As you can see, it is going to give you instructions to actually create the contract on chain. We just copy and paste this our console and hit enter. Oh, we need to add some Bootcamp. I'm just lazy, so let's do one. And you can see it succeeded. After it succeeded, you could go visit this Bootcamp URL, but it's not going to work here because I have to. It's at a different domain, so I have to add this to my host file very fast. And okay, yeah. And now, basically, it's going through the same web server as the domain agency. The web server just extracts the from the domain domain which SBRT it's going to try to serve and get all the relevant information. So we could see that this is the contract we just created, and to confirm that, we can see the contract hash matches here, and we can also check it with our Explorer, and we could see it's here, and it's just originated. And if we see the way that it is originated, we can see that it is originated by a smart contract call from Alice to our broker contract, which is going to generate an internal origination operation that generates which originates this contract. So everything is expected. Excuse me. And let's try to perform a withdrawal here. I'll just ignore this space. Agree. And let's beneficiary. Let's do ACC01 this time. Amount set to. Let's just submit. And the source address. I have to put in Alice. Oh, let's try to do ACC01, which is not in the owner list. Let's see what happens. Yeah, this situation fails. So we have to do start over and actually do, yeah, that is amount to, and see the source address. Simulation finishes, and we got the instructions. Just copy, paste, and it's done. Let's try to refresh, and you can see it's applied. Alright, that concludes our demo, and let's go back to our slides. Let's head into the technical architecture section. So in this section, I'm going to give a high-level overview because we don't have too much time. I want to pick up a few important aspects to understand wholly, at a very high level of our architecture. And after that overview, we're going to look into a few, from my perspective, the very interesting parts of the architecture in understanding how our current prototype is working. So let's get started. So the technical architecture. So basically, for our prototype TSCA, TSCA agency to work, we have 5 fundamental system components. The first one is the agency server, which is an API server that basically provides API calls, APIs. Excuse me. It's basically API servers, so the client application could request the listing of all available templates and actually issue API calls to originate contract instances or invoke contract instances with the interactions user want to. And so a little bit of terminology in our prototype TSCA, each template that is listed on the agency is called a book, and each instance, smart contract instance, originated from those books are called spirits. The reason it's called spirits is, well, there's a story, but in short, we don't call it a contract because it's kind of confusing. In our current implementation, there could be multiple, we support multiple on-chain smart contracts for a single instance of those templates. And so we also have a concept called spell, which is basically at the interface level, how you talk to those templates and those, the books and those spirits. So there is an origination, Genesis spell. We actually call that a spell of Genesis, which is what you use to provide the parameters to the template to originate a spirit. And to interact with those spirits, there's spell to spirit, which the end users could use to interact with the contracts that has already been originated. So that's what the agency service does. And of course, the agency service implemented its functionalities, talking to an index server and also and Tezos node for the injection of actual on-chain operations. And other than the agency server, we also have a web server, which serves the main agency, the marketplace SPA. SPA stands for single page application, and also the UI website made for each contract template. As I have shown, each contract, every spirit has its own URL that you can go to, and the URL is a separate domain, so that's a whole website. And that kind of a little bit unconventional handling is done by this web server. Oh yeah, and as I mentioned, there's what we call the website for each spirit is called a Bootcamp. And the next component is what we call broker contract. That is basically a smart contract that the agency server talks to when it needs to originate an instance for a template. So all of the actual on-chain underlying smart contracts that composes spirits are originated by this broker contract. And the broker contract also handles fee collection. And there are some illustration what you can do with the broker contract. And the next component is the actual contract template. So as I said before, all of those actual on-chain contracts are created by the broker contract. And the broker contract does so. The broker contract itself is very generic. So the basic idea is that the administrator of a TSCA agency uploads the template code to the broker contract, so that the agency server could send origination requests to the broker contract. And the broker contract is going to take the Genesis parameter. Genesis parameter is translated from the Genesis spell. If you wonder what's the difference, the broker contract would take the request with that Genesis parameter and call the template code that is uploaded, which would result in the contract origination. So the contract template is the actual code the broker contract is going to execute to get a what we actually call an ensemble, which is like a collection of smart contract code that's the and initialization function or initialization call. So the broker contract is going to originate the contracts in this ensemble and call and execute the initialization invocations. And we call those kind of contract template the code snippet to generate the ensemble and the initialization invocation, CCGEN. I'm not going to discuss too much about it, but that's how we call it. So basically, if you see CCGEN in later of this presentation, it means it's a contract template. And the last piece is a book. We have introduced that a book is basically the unit of listing for smart contracts on our agency. And oh yeah, I need to turn to the next slide. So book is a little bit complicated. So basically, it's a unit of listing, but in order to make it easy for the end user to select and use a smart contract template on the agency, we require some additional information as well as some operational components. So in our current architecture in the prototype, the book itself contains the smart contract template and also related descriptive information. And to use the book with the current implementation of TSCA, you also need what is called the template version and the bootcamp. Bootcamp is what we just discussed. What we just discussed before, and there is one web app registered at the agency at the time that is going to be used to display the information and provide interaction options to all of the spirits originated from this certain book. We're going to talk about that in details later. But now just focusing on the template version a little bit more. So, excuse me. On the agency to use a book, because the user don't talk directly to the broker contract to invoke those contract templates, I mean CCGEN, the TMPL versions is a bundle of you can say code that provide some additional operational components. One of them is called spell interpreters. That is what is used to convert the spell of Genesis and the spell to spirits into Michelson data, so you can actually send those to the on-chain contracts, including the broker. And a template version also provides form to build those spells. So this is the user interface part of this story, and they are called spell assistants. And you can also define utility functions to interpret the on-chain status of spirits. So for the spirits that is deployed on the blockchain, their states or status, depends on how you call it, are described in Michelson, which is a little bit awkward to work with, for example, in a browser. And for that reason, we allow you to include named spirit interpreters in a TMPL version bundle to interpret those Michelson data and translate them into, for example, JSON or as expression if you like. So that is spirit interpreters, and basically a TMPL version is a collection of spell interpreters, spell assistants, and spell interpreters to help the operation of the agency, and also the web app, as you can see later. So to dive into more details, well, later on I'm going to give more details on the broker contract and CCGEN, which is the main stuff for the contract template, and talking more about book and template version and Bootcamp Interface. So firstly, the broker contract. The broker contract is written in Scamo. Scamo is basically a compiler to compile a subset of OCaml to Michelson. So we can write a smart contract in basically OCaml. And our current implementation of the broker contract is in Scamo. And I'm not going to show you all the code of it, but what is shown here is the storage of a broker and the messages, like the entry point for the smart contract calls. So it's basically, as you can see here, if you are the administrator of the broker, you can upload new templates, and you can configure the templates. Basically, the configuration means whether it's enabled, disabled, and how much fee you are supposed to collect from this templates. And you can also add the domains, remove the domains, and configure broker. It's basically the same story as config templates. And after you upload and enable and configure your template, you can request the Genesis. On the actual blockchain, the Genesis request will be sent from the user that is trying to originate a spirit. So this method is going to be invoked directly by the user's account. And if everything matches up, the broker contract is going to take the incoming amount in this request and collect the fees and make the spirit, the underlying, originated underlying smart contract, like according to this Genesis request. And that's basically how the broker functions. And if you look at the broker store a little bit, it has some information fields, banner especially, and the most interesting parts are these three components: the templates, instances, instance index. So in the instance bitmap, basically what we store is the template descriptor, which I don't have the type displayed here, but basically a template descriptor holds is a CCGEN, which is a micro snippet, plus some configuration data. And an entry in this bitmap is basically a template registered in this in a broker instance. And instances here holds all of the spirits that has been originated from this broker. And each of them are spirit descriptors, and the spirit descriptors they are mostly for technical reasons. They hold, for example, the physical address of each underlying smart contracts, on-chain smart contracts that forms a spirit. And we have an instance index, which is basically a reverse index on the instances that tell you that given a spirit hash, which is the identity for a spirit, and give you the idea into the index into this bitmap where the instance is. So basically that's the broker contract. Oh, I'm sorry. I actually have the template descriptor, more detailed template descriptor listed here. As you can see, it's basically the CCGEN snippet and its identity, which is a hash, and some metadata. So that's the broker contract, and let's move to CCGEN. So this, what is given here is, you could see it as the effective type, if you're in OCaml world, for the CCGEN spirit, the CCGEN snippet. So each CCGEN would have two parts. One is the generation program, which actually generates, as you can see here, the code for the underlying contract that implements a spirit, and which, of course, taking the genesis parameter and initial total balance. And because it's returning a list of description of the new contract, you can see that you can actually have multiple underlying smart contracts implemented a single spirit. And there's also another part called initprog, which is short for initialization program. What this does is that it takes the same genesis parameter as the initial balance, and also the physical address of each component contract in the spirit, so that it can generate a list of initialization message to those contracts to initialize the state of the spirit, the underlying smart contract of the spirit. Why this is needed? It's mostly for technical reasons. The main reason, the primary reason, is that when you are generating multiple smart contracts, you don't know the address of the other smart contracts. So if you want to store, for example, if you have a spirit that consists of two smart contracts, A and B, and you want B to know the address of A, you have to use such a mechanism, which is basically what CCGEN does. And there are some supported types, oopsie, down here, so that you can actually read the whole type of CCGEN. And that basically wraps up what CCGEN does. And let's go ahead to a book and template version and Bootcamp. So firstly, a book entry in the current version of TSCA is what you could see here. So basically, there's an identity, there's the book hash, which is the identity is how you refer to it. It's basically like a Git commit hash and a branch name, kind of like that. And its title, its synopsis, and the template hash. The template hash is basically the hash of a CCGEN. So there is a 1-to-1 relationship. Actually, you can have multiple books for a single template, but we get the idea. And the provider basically is information about who provided this contract, this book, and the contract parameters, which we have seen in the demo, the contract terms we also have seen in the demo, and the contract accounts in the demo also, and the specification list. Those basically describes the smart contract to the user. And what the agency operator are supposed to do is to basically check whether those information are correct, providing the actual template. And oh yeah, so basically the book entity has nothing very special. But the GMPL version is probably more interesting. What we have here, a GMPL version, is that, of course, it links to a specific template, and it has its own hash, its own identity, I mean. And as you can see, there's a Genesis spell interpreter, there's an invocation spell interpreter, and those they both consist of the spell interpreter components that I discussed before. The reason we have separated them is because the type are a little bit different. So this slide shows what is called a book SDK, which basically abstracts all of the implemented details or to deal with microservice, so that you can have a nice interface to work with. And that is to be used mainly in Spirit Interpreter. As you can see here, it's taking a book SDK, and it's going to take Spirit status, which is going to be the on-chain status of the underlying smart contracts composing of a Spirit. But our against are microservice. The status are described in microservice, so you may want to use the API provided by the book SDK to convert that into JSON, something like that. And here, let's have a look at the spell assistant. So in TSCA, a spell assistant is given as a data structure, you can see here. So basically, each instance of this type would implement a form that is displayed to the user. So that has form title, form description, and there's a description for the major button, and a description for the fields in the form. And you see what that's composed of. There is basically identification, and whether it's mandated or not, a description, a name, and most importantly, its type. Field type, it could be an atom or a list of atoms, where an atom could be basically an input box for example, an amount, a Tezos address, and so on. We have, quite a useful collection right now, and this could be expanded as needed. And go back to the spell assistant. So basically we have a list of fields, and we have a form interpreter. Basically how it works is that the web application is going to take this data and transform all the data into a web form to present to the user. So the user could input the parameters for like a generation call or an interaction call. And after the user is done and click the major button, the form interpreter is going to be called, which takes parameters like a book SDK, which is just what is mentioned before, and it is going to take the form content, like a list, associated list of the field code to the actual user input. And what the interpreter is supposed to give back is when the form, the input the user has filled in the form is valid, it's supposed to produce a spell. For example, the spell to a spell of Genesis or a spell to instance. Or in the case that the form input is invalid, it's going to provide error messages. So the web application could display it to the user. The good thing of this level of complexity, if you like to call it, is that we're not using HTML and JavaScript here. So I would imagine that it is possible to implement a displayer for spell assistant on, for example, a very resource-constrained hardware wallet. And that is what is interesting about that. So I believe that's enough for the template version. And we're going to move into Bootcamp interface. A Bootcamp, as discussed, as introduced before, is basically the web application that the provider of a book creates so that the instance, the spirit originated from those books could have a nice web-based user interface. And so the interface here basically means the API for developers to create a Bootcamp. And the slides are divided into two parts. One is how do you do routing in the Bootcamp. So, and the next one is how do you actually interact with the TSCA agency server to get for example, specific information about the spirit you are trying to deal with. So, regarding the routing, basically a Bootcamp is a bundle. Think about the tar file, a zip file of a static site. So basically a bunch of HTML files and JavaScript files, images, and CSS, something like that. And because the agency is supposed to be very generic and different types of books and bootcamps from different providers are supposed to work in the same way, there is a special routing mechanism here. And so how to do it here is that you create a routing specification, like in a text file in the bundle, and the current routing mechanism supports 3 types of routes. This is an example, or I believe this is for the frozen Bootcamp, the example we just demoed before. Basically there are 3 types. The first one is resource mapping, which is the first and second line says that you basically just maps a URL to a certain file in the bundle. And there are resource directory mapping, which shows in the line 3 and through line 5 here. So basically, it's like serving static. It's for serving static assets. And there's a wildcard mapping, in example L4. This is used for example, you want to show an error page, or you want to implement the SPA, you can use this one. So this mechanism basically provides flexibility on how you can structure your Bootcamp. And this also enables a single page application implementation. But you may wonder if the site, if the Bootcamp is basically a static site, how it's going to provide dynamic information to the user and interaction. And that is done through the Bootcamp API. The way it works is that in a Bootcamp, we have an example of the SPA style HTML page here. You will request a JavaScript library, which is at this fixed URL. And when the web server, when the agency web server sees a request at this address, it's going to return a JavaScript API library. And through this library, you can query information about the spirit that this current Bootcamp is supposed to deal with. You can either get the raw index data or the information interpreted by Spirit interpreter that is included in the template version. And you can also request to display a spell assistant to initialize on-chain interaction with the contract. And basically that's the mechanism for Bootcamp. That's how you can write a Bootcamp. So we have created 3 smart contract templates. Well, CCGEN plus book, the book information and template version, and also Bootcamp. Basically a set of the stuff you need to list them in the agency. And they are all certified with Michelcock. Actually, they are developed with Michelcock, which means there are properties that we have verified formally. And yeah, so we have a book of Graveyard and a book of Frozen, book of crowdfunding. I believe all of them are useful to some extent. And of course, the most challenging one is the crowdfunding. All right, I think I'm running out of time. So If you have any question, please ask.
Okay, thank you, Haochen. So there are a couple of questions already. Jan asks, do you have sanity checks to ensure that multiple instantiations are well formed? Typically, how do you ensure that multiple contracts originated by a given template correctly interact with each other?
So right now, how the multiple smart contracts interact with each other within the same spirit to the developer of the smart contract. So I'm very sure about all the notation of sanity here, but that's basically the responsibility of the providers.
Okay. So Jan also asks, I assume that a lot of code is duplicated each time a template is instantiated. How much will TSCA be using the forthcoming global table of constants? That is, the ability to register large chunks of Michelson in a table and to refer to them in originated contracts to save storage space?
We have heard about that feature, but we haven't looked into that. So right now, every instance of the contract has duplicated code.
Okay. And also Jan asks, what property did you verify with Mishokok? Did you go beyond functional correctness?
We have checked a few security properties, if you like to call that. And I can show you briefly about the frozen contract we have done.
Do you need to share your screen?
Yes, I would like to.
Okay, I will give you up the sharing possibility.
Basically, for the frozen contract, we have certified we have proved two lemmas about the regarding its properties. The first one, frozen correct, states that, for example, the transaction amount of invocation must equal to 0, which means that you cannot add more funds to the contract. And the second ensures that the source of invocation for withdrawal request is one of those listed in the fund owners. The third is the timestamp of the invocation must be greater or equal to the unfrozen. And the fourth one says, the amount request for the withdrawal must be less or equal to the contract. The last one says that, the withdrawal amount must be greater than 0. So this one is a mixture of functional correctness and security properties. And the other one is frozen preserved storage, which says that after the contract is originated, the parameters cannot be changed. So, for example, those are the properties, the kind of properties we have certified for the smart contracts.
Well, that seems to be the end of it. There's no more questions. So thank you again, Haochen Xie, for your presentation.
Thank you for hosting. And thank you everyone for joining.
Okay, bye.